Okay, so today we are going to continue on in Chapter 6. We've, got you all set up for the project, and what we're going to do today is now we're going to switch back to Chapter 6, and once you hand in your projects, we'll get those graded and handed back, and we'll be working on Chapter 6 here, and then we'll switch back to Chapter 9 for the last milestone. And by the way, let me just tell you that this parsing phase milestone of the project is by far the most extensive and difficult. Code generation is just going to be very easy because you've already done the parsing. The code generation will it won't be hard at all. So once you've gotten this done, you're 90% there, 85% there. Okay, so now what we're going to do today is we're just going to do one translation. We are going to see how to call a non-void function in C, how to translate that, a non-void function call in C. And not only that, but we're going to see how recursion works. So this is going to be, we're going to look at a program with a function that calls itself. And it's going to be one of the ones that we looked at way back at the beginning of the course when we were looking at C, the C programming language. So let's review. To call a non-void function in C, well, here it is. Maybe I should hide this slide. Here. What four things do you have to push when you call a non-void function? The first thing is what? Storage for the return value. Second is what? Push the parameters. The third one is what? Push the return address. And then the fourth is what? Storage for the local variables. So here it is on the slide. Push storage for the return value, push the actual parameters, push the return address, and push storage for the local variables. Now let me ask you this. Who does push storage for the return value? Is that the caller or the callee? That's the caller. Who pushes the actual parameters? The caller or the callee? The caller. Who pushes the return address? The caller or the callee? The caller. But who pushes storage for the local variables? The callee. So now we've seen how that works before. Only thing that's different now is that we're going to be dealing with a function that is non-void. And here is the program we are going to translate. Figure 6.25. Now this is bin coef, which stands for what? Binary coefficient. Do you remember having to construct the runtime stack for this when we looked at it in C? I hope so, because we had a homework assignment that showed how this worked. Are you with me? So now we are revisiting this, and we're going to see how it actually happens in assembly language. Now, it's very mechanical. This can be automated. This translation is automated by compilers. It's a very mechanical thing, but we will see exactly now how this runtime stack gets allocated. And so I think the first thing we should do is draw the runtime stack before the stack pointer before we subtract from the stack pointer to push, and then we'll look at the stack relative addresses both before and after we actually do the push by subtracting the stack pointer. Okay, so that's always the way we approach these problems. Okay, so now let's take a look. In the main program, first of all, are there any local variables in the main program, yes or no? Are there any, correct, no. Are there any global variables in the program? Any global variables, yes or no? No. So basically there's nothing in the main program. There's no locals, it's not accessing any globals. And all it is just one printf statement. It's printf binomial coefficient 3, 1, well, the string binomial coefficient 3, 1 equals, and then we have a placeholder for the what? For the thing that gets printed out, and then we have a bash n, right? And then what is going to go in the placeholder? Bin coef what? 3, 1. Yeah, so those are constants. We're calling them so the actual parameters now are constants. And so it will call this, and then once it calls it, it will return the value, and that value is what will be printed out. Now, does everybody see how the main program works? Are we good? Are we good? Okay. And so now let's draw the runtime stack for this. And then bin, oh, by the way, bin coefficient has how many parameters? 2, n, and k. And does it have local variables, yes or no? Yes, it does. So we've seen this runtime stack before. Now we're going to see it in detail, in some more detail. So check this out, you guys. So first of all, here's the runtime stack. Now, let's count how many items are going to be on the runtime stack. First will be what? Good point. Ret value. Okay, storage for the return value. Ret val. Then what will be next on the stack? The parameters, right? And what are the actual parameters are? Yeah, the actual parameters are 3 and 1. Those values will be pushed on, but then how do we label them? We label them with the what? The formals. So this is what? N is correct, and this is what? K. Now, is everybody clear on that? Okay, now, then what was the next thing that got pushed on?
Do you push 3 and 1 to n?
Well, when we execute the program, the 3 will be pushed to here, and the 1 will be pushed to here. But those will be, it's just call by value. Those values will be on the runtime stack. Is everybody clear? And now what was the next thing? Return address. By the way, what statement executes to push the return address? What assembly language statement? Correct. Call. Good job. Okay, so this is return address. And then what are the local variables? First one is what? Y1. And the next one is Y2. Okay, so this whole thing is called a what? What is this whole thing called? It has two names. Do you remember? All of these together collectively is called a what? A stack frame. Yeah, there's another word for it. It starts with an A. Do you remember? Activation record. Did you remember that? Activation record? Okay. All right, so here it is. Now, when the stack pointer is down here, let me see how to do this. When the stack pointer is down here, when this, is this showing up on the video? Okay, when the stack pointer is down here, what is this ret val relative to the stack pointer? What is its address? -2. And by the way, these are all 2 bytes, right? They're integers, right? And the return address is a 2 byte. And what is the address? What is this n? -4. And what is this k? -6. On the other hand, when the stack pointer is here, what's the address of the Y1? Of the Y2? 0, Y1, 2, return address, 4, K, 6, N, 8, ret val, 10. Okay, so now with this in mind, let's start. Let's go ahead and get started. So now, who wants to go first? All right, you get it. Branch to main is right. And now I think what we'll do is, let's just go ahead and go down to main and start coding main, all right? So let's put main here. And now, okay, so you're next. Yeah, so we don't have to sub SP because there's no local variables in main. And so stro, string output, because we've got a string output, that binomial coefficient, blah, blah, blah. So stro, what should we stro? String output what? Message direct. Good. Okay. And then, so that will print out bin coefficient 3, 1 equals. And now what we have to do is what? Now we actually have to call bin coefficient 3, 1. Now, here's the thing. What we're going to do is we're going to put the actual parameter here and the actual parameter here, and then we're going to sub SP. So how do we put the first actual parameter here?
Load it.
So load what?
Load word
load word accumulator, and what's, 3 addressing mode? Immediate. So is everybody clear on that? And then how do we, so that gets that into the accumulator. Now how do we get that here? Okay, so you're right. Store word accumulator where? We want to put it here. So store word where? -4 addressing mode? S, stack relative. So that will put, so what that'll do is that will put the 3 right there. Is everybody clear? That'll put, so that'll here, let's go ahead and write it down. That'll put the 3 there. Now, how do we get the 1 in here? So next. Load word accumulator. 1 addressing. Immediate. Next. Yes. Negative what? Yes. Addressing mode? Yes. Stack relative. Are we good? Is everybody so far so good? And now what do we have to do? Now how do we actually, now we got to get the stack pointer up to here so that we can, when we do the call, the return address will be here. So now what do we do? Sub SP by how much? Sub SP by 6, addressing mode? Immediate. Now this, what are we doing? Well, and we need trace tags here. This, what are we doing? What are we literally doing? We are doing what? What are we literally doing? Pushing. And what are we pushing? Oh, by the way, this one would be here. Okay, so we're actually pushing what? Storage for the return value and N and K in this 1 minus 6. So what do we, so what do we do? So we say push what? And we do this in order. Hashtag what?
Do you really write ret val?
Yeah, you do. Ret val is going to, yeah. So ret val. And then what else? Hashtag ret val, hashtag N, and hashtag what? Okay. Is everybody clear on that? Okay. Now, next. Oh, yes, call. Call what? Mm-hmm. And that will put, and so now the stack pointer will be here. Now, I'll tell you what, let's do. This time, let's go ahead and finish main out, all right, instead of going up and coding the function itself. This time, let's finish it out. Now, when we call bin coefficient, it will go up there, it will go up here and do blah, 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 blah. And furthermore, it will put the what? The return value here, right? Are you with me? It will put the return value here. So now what we have to do is, we do a sub SP, we do a call, and then after we do the call, what do we do? We have to undo this. So how do we undo this? Good. Add SP, addressing, how much? 6 addressing mode? Good, excellent. But now what are we doing? We're doing pop, but now what do we pop off? Opposite order, so K, exactly. So hashtag K, hashtag N, hashtag ret val. All right? And now let's take a look. Now where is the stack pointer? The stack pointer is back down here. So now here's the next thing that main program has to do. It has to output the value of bin coefficient in that %d placeholder. But where is that value? What has that function call done? It has put that value here. Okay? So how do we output that? I forget who's next. Okay. Do you know how to output that? Sure. Why the heck not? Deso from where? Yes. -2. Addressing mode? S. Yeah.
So popping doesn't do anything about what's stored in those locations?
Correct. That is a very good observation. When you add SP, it leaves those values there on the runtime stack. And if you, by the way, if you ever do another call, then those will be overwritten. So, but that value, that return value is still there. Yeah, when you did add SP. So everybody, okay, so now what's the very last thing in the main program that we have to do? We still have to do a what? A new line, yeah. So how do we do the new line? Load byte accumulator, what? Yeah, it's a single quote, what? Dash n, back, addressing, immediate. Then store byte accumulator. Now this is memory mapped IO.
Right, care out.
Care out. Direct, because that output port is at a fixed location in memory. It's wired in there at that fixed location in memory, and that fixed location is at care out. Okay, and now what? You have it easy, because we're basically done. Just stop. Stop. And now what? Well, actually not yet. Bzz. There's something left over up here.
Okay,
So what? Message colon dot ASCII. And then what? Yeah. Quote, bin coefficient, paren, dot, dot, dot. All right? Is everybody good? And now what? Oh, yeah, question? Okay. And now what's now what? Dot in. Okay, you got it easy. Dot in. Okay, now question? Yes. Yes, this is where the stack pointer is when the main program is first called. And this is where the stack pointer will be when we are executing the function. Good point. Good observation. Is everybody, are we good? Okay, so now here we go. Now let's write the code for the function. So here we go. So we did stro, load word, store word, blah, 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 and then sub SP and then call. So when we do the call, where will the stack pointer be? The stack pointer will be right here, right? So now let's do, now we're going to have to define some things. Now, what is the stack pointer going to have, what is the function going to have to refer to here in the code? What does the function, what are all these computations inside bincoef? What is it processing? What variables, what does it have access to here? N and K and Y1 and Y2 and what's another thing that it does? Return something. So it's going to have to have access to what? To all of these. So we have to define those. Okay, so branch domain. So here is our bin coefficient. Well, it's a comment. I'm just writing this as a comment. I'm just saying this is bin coefficient int n, int k, just for documentation. All right? And so now, we're going to have to go up and down here. Okay, so now, I think the convention is to do this one. So what's the value of ret val? We have to define ret val. Where SP is going to be here.
that would be
10. So how do we do that? So here we say what? Ret val colon, and then how do we define it? Yes. Dot equate 10. All right. Next will be what?
Colon dot equate.
N colon dot equate what? 8. So N dot equate 8. Next, K dot equate 6. Okay, next, up and down, up and down. Y1 dot equate what? Excellent. Y1. Oh, by the way, we've been forgetting our, yeah, but anyway, we'll come back to that since we're already on a roll. And then what? Yes. So Y2 dot equate 0. Now, no, but we need, what is this? This is a, that's just a ret val. But how do we want to print it out? How do we want it printed out in the debugger? What is its type? Its type is a what? Well, here, how do you know what type it is based on the code here? What does it say? What does it say? Bin, this was, this wasn't quite right. Yes, int. Oh, what was it? Int NNK. Yeah. So what is the type of ret val? Int. So how do we? So what is this? So this is return value. Yes. Good. 2-byte decimal. And what about this? This is a what? Yeah. This is a formal parameter, right? So this is a formal parameter. And what is its type? 2-byte decimal. This is a what? Formal parameter, hashtag 2D. This is a what? Global or local? Local variable, hashtag what? Integer, local variable. Good, we're all set. Now, I've kind of forgotten whose turn it is. Now the first executable statement in bin coefficient, right? So we do sub SP, excellent, because what are we doing? Pushing the what? The Y1 and Y2, very good. So sub SP, how much? For addressing mode? Immediate. And what are we pushing here? Hashtag Y1, hashtag Y2. Yeah.
So when you do the call, that automatically subs.
No. Well, good question. Here, let's review that. When we do this call, okay, remember, we did a sub SP6 here, so that put this here. When we do the call, that puts it, yes, it automatically, that's part of the call.
You don't have to sub for the return address.
That is correct. In fact, if you look at the RTL specification of the call, it does. SP gets SP minus 2, you know, and then mem sub SP gets PC, and then PC gets operand. Are you with me? So yeah, so it'll be here. So we sub 2 more, and then that gets us up to here. All right, you guys are good. This is good. Now we have this if statement. If k equals 0 or n equals k. Now how are we going to do that? Who's next? Oh, okay. Do you know how to do that? Load word accumulator what? K, good. So this is load word accumulator K. Now addressing mode? S, because we're on the runtime stack. And then we're comparing that with what? Okay, so let's go ahead and do it explicitly. So compare word accumulator. What? 0 addressing mode? Immediate. Now we got to figure out the branch. Okay, so now how do we know that we have to do the return 1 right off the bat? Yes. So this is branch, so what is this? Branch what? BR what? Well, that's what I thought that's what we just figured out. We are branching, now see here what we are doing is we are branching to the return 1. Because we have to have the second test has to be below this. Yeah, oh yeah, you see how this branch around, so what we have to do is we have to branch around the second test. So now we're not branching to the else, we're branching to the if, then.
So what would be a good symbol?
Oh, well, but before we do the symbol, branch what? Branch if equal to, and let's, I don't know, then, if then, or then. No, it's not the if. No, it's not the if because the if. If I don't remember the symbol that I used in the code. Let's just say then. You know, like if something, then something. See what I'm saying? But I don't know. Might be a different. And branch equal to then. And now, how do we do the next test? Load word accumulator what? And addressing mode? Good. And then what? We have to, with what? Yes. Compare word accumulator K. Addressing mode? Yes. All right. And now where do we, now we're going to branch to, when do we, this next statement will be the return 1. So now we want, when do we know that we want to branch to the else? Exactly. So BR what? NE. Branch if not equal to the, now we can go to the where? To the else. And so this part will be the what? This part will be the then from here. Is everybody clear on how we're setting this up? I don't remember in the code in the text what it's called, but whatever. All right. So now the question is, how do we return 1? Let me see. Who is okay. How do we return 1? So now, how do we return 1? Well, what do we have to do? We got to put what? We got to put a 1 here.
Yeah. So load word accumulator.
Okay, so load word accumulator. 1 addressing mode. Immediate. Excellent. You guys are good. And then what? Oh, and now, yeah, and now what does it say? It says return. So when you do a return, see, look, there's 2 returns in this code. This is, we are returning right off the bat. So how do we return? How do we return? What do we have to do? We have to do what?
Well, don't we have to store?
Oh, we forgot to store it. Load word accumulator 1 immediate. Yeah, sorry. Excellent. No. No. You don't want to put it here, -2. You want to put it here. Well, but we don't say 10. What do we say?
Oh, I don't know.
Ret val. Okay, so store word accumulator what? Ret val S. Oh, I'm glad you caught that. Mistake of mine. And now what do we have to do before we can actually do ret? Add SP, how much? Did you say 4? Oh, 4? Oh, okay, add SP 4, how much? Addressing mode? Immediate, and what are we doing here? And what are we popping? Hashtag Y2, hashtag Y1, and then what? Who's next? Yes, and what's the mnemonic for that? Ret. Exactly. Now, is everybody clear on how we did that? You guys are good. This can be automated. All this stuff we're doing. This is what a compiler does. This is how a compiler generates code. It literally does this. Okay? And now, but we're only halfway done, now we have to do what? Y1 gets bin coefficient n-1k, and so where are we now? We're at the what? Now we're at the else, right? So let me see, where did we branch? Here, we branched if not equal to else. So now here we are at else. All right? So now how do we do, oh! Now what we're doing is y1 gets bin coefficient n-1 comma k. So now what's going to happen, you guys? What's going to happen is we're here. So now what's going to happen is when our SP is here, what's going to eventually get? Another stack frame is going to get. So what's it going to be? Okay, so here's the bottom of this stack frame, and there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so, and our stack pointer is here, all right, and this is going to be what? This is going to be, yeah, this will be ret val. This will be.
Does it say like 2 or something?
No. And this is going to be n, this is going to be k, this is going to be what? Ret address. This is going to be what? Oh, y1, and this is going to be y2. Ah, look at this.
Oh, because it'll still be those same numbers.
Yes, the SP is, now this SP is here, so this will be negative, boom, right? And when it's, the SP is up here, it'll be the same. Is that slick? Is that slick? Okay, so now we got to do the same thing, but look, it's, so now let me see. So how do we get, what are we calling? Bin coefficient what? Here, y1 gets bin coefficient what? N minus 1. So what do we have to do? We got to put what? We got to take this n, watch this you guys. We got to take this n minus 1 and put it where? In there. Yeah? So how do we do that? Who's next? I forget who's next. Somebody fess up. Oh, okay. Okay. So now how are we going to get n? First of all, we got to compute the n minus 1. So how do we compute our n minus 1? Load word accumulator, what? N addressing mode? Stack relative. Now how do we subtract 1 from it?
Just sub, or not, what is it, sub? I don't know.
Yeah, isn't there a subaccumulator? Is it SUBA?
I think so.
Oh, it's been so long since I've done a subtract, I don't remember the
Yeah, because add is just.
ADDA and SUBA. It is, yeah. Okay, so, oops, wrong column. So, sub A, what? 1 addressing mode? Immediate. And now we got to put it, okay, so now we took this, we subtracted 1, so now, and our stack point is here, so how do we put it here? So next, store word accumulator, negative what? Oh, let's look. This one is 2, negative 2, this one is what? Negative 4. Is everybody clear? So store word accumulator, negative 4 addressing mode? Yes. And now we got to, and now what does it say? The same K gets put where? So this K gets put here, right? Is everybody clear? So how do we do that? Load word accumulator, K addressing, and then what? Store word accumulator. Now where? It's boom, boom, boom.
-4.
Negative, I don't think so.
Oh, -6.
-6. Okay, store word accumulator, -6, addressing,
S.
stack relative. And now what? Sub SP. How much? 6 addressing, immediate. And we're pushing what? Hashtag ret val, hashtag n. Getting small here. Hashtag n, hashtag k. All right. And now what? And now what? So we did boom, boom, boom here. And so now this is a recursive call. So what? Do you know? You want to pass? Yeah? Not branch, we're calling a function recursively. Call, yeah. Call what? Bin coefficient. All right? And now what's that going to do? That's going to come up here, and it's going to do the sub SP, and it's do its thing. All right? And then after we get back from this call, what do? Add SP. So we did sub SP here, so we do what? add SP6 addressing, immediate, and what are we doing here? Pop,
hash
K,
N
N.
red val.
You guys are good. And ret val. Okay? And now that we've done that, what does it say? It says Y1 gets. So how does Y1 get that? Do you see what we're saying? It says, because now when it comes back, this will be here. And it says Y1 gets this. So our stack pointer's here. So how does this Y1 get this? Yes. Load word accumulator what? Load word accumulator ret val. Oh, no. Not, oh, sorry, not ret val. Because where is it? We don't want to put this one here. -2, good. So load word accumulator -2 addressing. Good. Load and then what? Store word accumulator to where? Because the code says Y1 gets. Y1 addressing mode? Yes, stack relative. All right, so that is Y1 gets bin coefficient. And now do you see how to do, I'm not going to bother to do the Y2 because it's the same thing. So how would you do, so here let's do ... So do you see you would do, you'd N -1, put it, K -1, put it, call, boom, boom, back. And then, so let's just say the Y2 gets whatever. So here is Y2 gets blah, blah, blah. And then after we've done that, how do we return Y1 plus Y2? How do we return Y1 plus Y2? We have to do what? So here we are, how do we return Y1 plus Y2? Load word accumulator what? Load word accumulator Y1. Then what? Add accumulator is correct. What? Y2. And then what? Oh yes. Stack relative. And then what? Store word accumulator into what? Ret val. S. And then, wait, did we have an end if? Oh, did we forget?
Well, there's nothing there.
No, but after we did return, return, we don't need one because we did return 1 right off the bat. Yeah, okay, so what's the last thing here? Who's next? I've lost track. So the very last thing we have to, well, it's the same thing that we did before we did return.
So then would it be add SP?
Yes. Add SP4 addressing, immediate, and pop. Is it Y1, Y2? Y2, Y1, right. Hashtag Y2, hashtag Y1, and we're done. We've done except for that. Yeah? Now here, let's see if we did it right. Did we call it then? Oh, we did call it then. Here's the code. Did we do it right?
You gotta add a return at the end, but
Say it again.
we didn't ret.
Oh, we forgot to ret. Wait. Oh, we forgot to ret here. Duh. I thought something was not quite right there. Otherwise, are we good? Check here. How about over here? Does this look good? Yeah, question?
Why is it 4 for add SP?
Why is it 4 for add SP at the end? Because at this point we have returned from So it's because of this. The stack pointer is here. We add 4 to get the stack pointer to here. The ret pops the return address and gets the stack pointer to here. And then in the caller, the caller will add SP6 to get it to here. That's why. That's that intermediate step. Good question. Now, I don't think this will take that long, but there is you want to see something really cool, if I do say so myself. Watch this. Okay, so here's our demo. So watch this. This is, I think it's 625. So here's all this code. Let's copy the source. Let's build it. And let's start debugging. Now watch this, and we'll give us a little space here. So check this out. It's branch to main. The first one is branch to main. So there we are in main, and we stro. So you see there's bin coefficient 3.1. Are you with me? And then now what is load word accumulator, store word accumulator to -4, load word accumulator, store word accumulator -6, sub SP. Now what happens when we do the sub SP? The ret val, the N, and the K. Huh? And then what? Call bin coefficient. So what does that put? Boom, the return address. So you see the return address is there on the, and now what? Now we're up in the function, and what does it do? Sub SP for Y1, Y, so there's the Y1, and there's the stack frame. Is that way cool? And now check this out. Load word accumulator, so the accumulator is loaded with the value of K, and then branch equal to, and then load word, and then compare word, and then branch if equal to. And so now we're going to, so now we're going to do the next stack frame. So load word accumulator N, this is the else part, right? So load accumulator N. Now check this out. Subtract 1 from it, so N is going to be 2. So you notice over here that the value in the accumulator is 2. All right, and then we'll store it. It's not visible yet because we haven't subtract. And then K, load K, the value of K is here, it's 1. And then, and now sub SP, and check this out. There's the ret val and the N and the K. And now what are we going to do? Make a recursive call. So what do we call? Boom. And then sub SP in the function itself, and what does it do? That same stuff. So there it is. And there's the other stack frame. And look, here, let's just, there goes another stack frame. Down, up, down. Look at this. Down, down, and another one up. Another one down, boom, 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 boom. And output is 3. So you can actually see, you know what you should do is if you're not clear on what each one of these steps does, this is in the app. You can go trace it through and study it and make sure that you can reproduce this. All right? So now guess what you have for Thursday? Guess what recursive program did you write the very first week of class? Or the first 1 or 2 weeks of class? Do you remember a C program, a recursive C program? Towers of Hanoi. So guess what you're going to do? You are going to do what for Thursday? Translate Towers of Hanoi. All right? So now you see how to do it.